So guys, welcome to our channel once again. In today's video on WAEC Physics Exam Revision Series, we have here these 10 WAEC repeated questions to answer on the topic equilibrium of forces. So guys, this video will be about conditions of equilibrium under parallel and non-parallel forces. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, a beam PQ pivoted at P carries a load of 80 newtons as shown above. Calculate the effort E required to keep it horizontal. Neglect the weight of the beam. So here, let's go ahead and solve this together. Let's consider that the clockwise moment will be also equal to the anti-clockwise moment here. So for this, we're going to have that 3 times E, or let's say 3E, is equal to 80 newtons times 0.5 meters. So guys, let's go ahead here. 0.5 times 80 is 40. So 3E is equal to 40 here. So in that case, E will be 40 over 3. And that's 13.3 Newton. And that's the answer to this question, option A. So let's go ahead and consider the next question, guys. So guys, question number 2 here says, a rectangular block of dimension 2.0 meters times 1.0 meters times 0.5 meters weighs 200 Newton. Calculate the maximum pressure exerted by the block on a horizontal floor. So guys, let's also go ahead and solve this together. Now, looking at this, we have been provided with the dimensions of the block. That's 2 times 1 times 0.5. And then we also have the force in newtons. That's 200 newtons. But then, we are looking for the maximum pressure. But let's recall that pressure is force over area. So we are going to have the maximum pressure when the block occupies the highest area within the floor. So that will be the area 2 times 1. That's 2 meters squared. So if we have 2 meters squared as the area now, we are going to actually calculate the pressure as 200 newtons over 2, and that's 100 newton, guys, and that's the answer to this question. Option A is the answer to this question, and that's it. So let's go ahead and consider the next question. So that's question number 3 here. It says, the diagram beside shows a box X of weight W resting on a plank PQ that has its lower end P hinged to a horizontal floor PR. The plank makes an angle of 90 degrees with the floor. Use this information to answer the questions below. As the end Q of the plank is raised, the component W normal to the plank will A. decrease, B. increase, C. be slightly greater than W, D. remain the same. So guys, the answer to this question is option A. The component of W normal to the plank will decrease, and that's it for this question. Let's go ahead and consider the next question. So that's question number 4 here. It says, suppose 3 identical steel balls Q, R, and S are placed on an undulating ground as illustrated in the diagram above. Which of the balls is/are in neutral equilibrium? We have Q, we have R, we have S. So option A says R only, option B S only, option C Q and S only. Option D, Q only. So guys, the answer to this question is option D, and that's Q only. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 5 here. It says, the diagram above illustrates a ball of mass M sliding down a plank inclined at an angle of theta to the horizontal. The normal force on the ball is A, mg sin theta, B, mg tan theta, C, mg cos theta, and D, mg cot theta. So guys, the answer to this question is option C, mg cos theta, and that's it for this question. So let's go ahead and consider the next question, guys. So guys, question number 6 here says, the diagram beside shows a box shows a box X of weight W resting on a plank PQ that has its lower end P hinged to a horizontal floor PR. The plank makes an angle theta with the floor. Use this information to answer the questions below. So we have here, if theta is equal to alpha at the time the box is just about to slide down the plank, the coefficient of static friction between the plank and the box is A, cos alpha, B, tan alpha, C, sin alpha, D, secant alpha. So guys, the answer to this question is option B, and that's tan alpha. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 7 here. It says, masses M1 and M2 at the 20 cm and 65 cm marks respectively of a uniform meter rule freely suspended at its center of gravity. If the meter rule balances horizontally, determine the ratio M2 is to M1. So guys, we are going to still have that the sum of the clockwise moment is also equal to the anti-clockwise moment. So having that the clockwise moment is equal to the anti-clockwise moment, we have a diagram of the meter rule here. So where the first mass will be at 20 cm mark, whereas the second mass will be at 65 cm mark. If we have this here already, let's go ahead and determine the midpoint here. That's 50 at point 50 here. So this is where it balances at its center of gravity here, 50. So now if this meter rule balances at 50, then it means the distance of M1 from this center is 50 minus 20, and that's 30 cm. So M1 is 30 cm away from the center, whereas M2 is 15 cm away from the center. That's 65 minus 50, that's 15 cm. So it means that 30 times M1 will be equal to 15 times M2. That's 30 M1 will be equal to 15 M2. So if 30 M1 is equal to 15 M2, it means that M2 is equal to 30 over 15 M1, and then M2 over M1 will now be equal to 30 over 15. So M2 over M1 is equal to 2 over 1. So the ratio here is 2:1, and that's option B. So guys, option B is the answer to this question. Let's go ahead and consider the next question here. So that's question number 8 here, guys. So question number 8 here says, the diagram above illustrates a uniform meter rule which is balanced on a pivot by some masses, calculate the value of n. So guys, looking at this meter rule here given to us, we are going to actually do a replicate of this. So we'll have this meter rule, and then we'll draw the angle here showing the midpoint or the center of gravity where it pivots. So here will be from a distance of 10 cm to the right, shows where the mass 100 gram is suspended, and then we have remaining 40 cm to the right here. So whereas from the left, from the tip of the roll to where the mass m is suspended, we have 10 cm here, and that's it. So let's also note that if this distance is 10 cm, it means that the distance from the mass to the center where it pivots will be 50 minus 10, and that's 40. So if we use that this anti-clockwise moment is equal to the clockwise moment, or let's say the clockwise moment is equal to the anti-clockwise moment, we are going to have that 40 m is equal to 10 times 100. So in that case, 40 m is equal to 1000. So if 40 m is equal to 1000, then m is equal to 1000 over 40. So that's 100 over 4, and that's 25 grams. So guys, option D is the answer to this question, and that's 25 grams. So let's go ahead and consider the next question, guys. So the question here says the resultant force in a couple is A, the product of the forces, B, infinite, C, 0, D, the sum of the forces. So guys, simply the answer to this question is 0. Now in a resultant, the resultant force in a couple is 0 because in a couple we have two forces that are equal and opposite. So in that case, we have F1 is equal to negative F2, right? So, or let's say F1 is equal to negative F1, or something like that. So, in that case, it means that if you add these two forces, that's the F1 and then the F2, it's going to give you the same value plus the negative value of the same value, and that will be a 0 as the outcome. So the resultant force here will be 0, and that's it for this question. So option C is the answer here. So let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says a body of mass m kg rests on a plane inclined at an angle theta to the horizontal. The component of the weight of the body parallel to the plane is A, mg sin theta, B, mg sec theta, C, mg cos theta, and D, mg tan theta. So guys, option A is the answer to this question, mg sin theta. And this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community where we'll post major updates on WAEC examination. Guys, this will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.